All right, so we're working on section 1.2 of the Intermediate Algebra book, and the topic is slope of a line. If you're following along in your textbook, that starts on page 19. All right, example 1 asked you to find the slope using the graph below, and I kind of reproduced the graph here. When you're finding slope from a graph, you're going to remember that slope is the ratio of rise over run. So on your graph here, you're going to draw a vertical and a horizontal line that connects. The intercepts are a good place if your line actually crosses right at a tick mark intercept. Otherwise, you're going to look for where your line does cross the tick mark so that you're counting whole units. So we're going to make a vertical line and a horizontal line, just like this. Now, the vertical line is the rise, and the horizontal line is the run. So if you count how many units that is, so how many units long is this rise? And it matches up to this space here. So this is 2 units long. So this rise is 2. So we'll put a 2 on that fraction there. This rise is 2. And then we're going to count the same for the run. The run is this distance right here, and it matches up to this distance. So this run is 4 units long. So the run is 4. So that we'll put that on the bottom of this fraction here. And then, of course, as with all fractions, we always reduce. So 2 over 4 reduces to be 1/2. So the slope of this line, based on this rise and this run, the slope of this line is 1/2. Okay, example 2 asks the same thing. Find the slope using the graph below. And again, I tried to reproduce the graph here. We're going to do the same thing we did before. We're going to use a vertical and a horizontal line to connect those 2 intercepts. The vertical is the rise, and the horizontal is the run. Slope is rise over run. Okay, so we're going to count how high is this rise, and this matches up to this distance, which we can see is 3 units. Now, if you're counting rise and run, you also need to look at the direction of the graph. This line goes downhill. This is a downhill slope. So this slope is a negative number. If you remember that downhill slopes are negatives, you don't have to put negatives on your rise and your run. So when I write this, I'm going to first determine the rise, and the run here is 2 because it matches up to this. When I write rise and run, I'm going to put a negative in front of them just because my line goes downhill, and then the rise over the run makes this a slope of -3 over 2. Just to reiterate that, let me scroll up a little bit, and we're going to talk about negative slope just a little bit here. There are actually 4 different kinds of slope. There are lines that go uphill. This is uphill. And there are lines that go downhill. Uphill lines that go like this have a positive slope. Downhill lines have a negative slope. And if you remember this, every time you look at a line, you can tell whether it should be a positive slope or a negative slope. The other 2 kinds of slope are horizontal lines. And these have a slope that equals 0. And vertical lines. These have a slope that's undefined or does not exist. I usually use the term undefined. That's really sloppy. I'm sorry. Let me see if we can write that a little bit better. That's better. Okay. We're going to move on to example 3, which is on page 21. At this point, if you're following along with your book, it asks you to find the slope of the line that passes through these 2 points, 5, 3, and negative 1, 3. To find the slope of a line when you don't have the graph, you're going to use the slope formula. The slope formula is y2 minus y1 over x2 minus x1. So if you look at your coordinates here, this is x1, y1, x2, y2. These are not exponents, they're just labels for the first x, the first y, the second x, the second y. So sometimes I write it up here, x1, y1, x2, y2. I didn't leave myself enough space to really do that. But I'm going to put these into the formula and then simplify it. So y2 minus y1, this would be y2, this would be y1, and that will be 3 minus 3. x2 minus x1 will be negative 1 minus 5. And then I simplify this. Well, of course, 3 minus 3 is 0. Negative 1 minus 5 will be negative 6. And you might think you're done here, but this fraction right here, this is not simplified. If I were grading a paper with this answer on it, I would not give full credit because all fractions need to be simplified. This fraction, 0 over negative 6, any fraction that has 0 in the numerator simplifies to equal 0. So your slope here, the slope of the line that passes through these 2 points is 0. Now what does that mean about the line? What kind of lines have a slope of 0? Well, we just talked about it on the previous page. Lines that have a slope of 0 are horizontal. I mean, I know this information is not required, but a lot of times some teachers will give extra credit for giving a little bit of extra information. So the slope of this line, and M stands for slope, is 0, and that means that it's a horizontal line. We're going to move on to example 4, which is the same type of question. Find the slope of the line that passes through the points negative 4, 1 and negative 4, 7. And that slope formula is y2 minus y1 over x2 minus x1. So again, this is x1, y1, x2, y2. So y2 minus y1 will be 7 minus 1. And x2 minus x1 will be negative 4 minus negative 4. And be careful of those minuses. Right now, it looks weird because I have these 2 minuses here, but why do I have these 2 minuses here? These subtractions right here are always here when you use the slope formula because they come from the formula. This extra subtraction here comes from this coordinate having a negative on it. So watch for these double negatives. This happens a lot, and a lot of students are fooled by this double negative here. Of course, the first step should be to clear those double negatives out because a negative minus a negative makes a positive. So this is actually going to be a plus here. So 7 minus 1 is 6, and negative 4 plus 4 is 0. And once again, this is not finished until you simplify. Now, this is not equal to 0. Fractions that have 0 in the denominator do not equal 0. When there's a 0 in the numerator, it equals 0. But a 0 in the denominator is a fraction that is undefined. And that's exactly how I would expect this answer to be expressed. This slope, and that's what M is undefined. And what kind of a line is a slope undefined? That's a vertical line. Again, this is only the required information, but a lot of professors, teachers will give some extra credit. You show you know a little bit more, that will be fine. All right, scroll it up here. Example 5, same type of question. Oops. Find the slope of the line that passes through the points negative 3, 2, and 4, 5. So again, that slope formula is y2 minus y1 over x2 minus x1. x1, y1, x2, y2. So y2 minus y1 will be 5 minus 2. And x2 minus x1 will be 4 minus negative 3. And again with the negatives. Be careful. You should always have these negatives because they come from the formula. This extra negative is on the coordinate. So then we simplify and we get 5 minus 2 is 3. 4 minus negative 3, these actually become plus, is 7. So this line has a slope. The line that goes through these 2 points has a slope of 3/7. Example 6 on the next page, the same type of question. Find the slope of the line that passes through the points -3, 2, and 8, -5. So the slope formula, y2 minus y1 over x2 minus x1. This is x1, y1, x2, y2. So y2 minus y1 will be -5 minus 2. x2 minus x1 will be 8 minus -3. The first thing you can do is cancel off those two negatives. -5 minus 2 is -7. 8 plus 3 is 11. So this is a slope of -7 over 11. All right, example 7 is a word problem. It's on page 22. I'm not going to write the whole problem out here, but I will read it to you. If you have your book handy, this is a good time to get it open so that you can kind of follow along. All right, the question says, on one of the Valencia campuses, the number of students enrolled in 2005 was 14,985. In 2010, this number increased to 17,982. Find the slope. Explain the meaning of the slope. So I'm just going to write this data down. In 2005, there were 14,985 students enrolled. In 2010, there were 17,982. The question is asking me to find the slope. So whenever you're finding slope, obviously you need two kinds of data, which we have here. We have years, we have number of students. So we're going to make ordered pairs out of these. The first ordered pair is going to be 2005 for X with 14,985 for Y. The second ordered pair is going to have 2010 for X, 17,982 for Y. Sometimes students try to put two kinds of data in the same ordered pair. Really, if you're making two ordered pairs, you need to have the same types of data for X and the same types of data for Y, and those two pieces of data need to match up in some way. So these two numbers match up as being the statistic for this year. So X is here, the year, and Y is the number of students. And then we can have X1, Y1, X2, Y2, so that we're ready to find a slope by using the slope formula. Y2 minus Y1 over X2 minus X1. So Y2 is here, minus Y1 will be 17,982 minus 14,985, and X2 minus X1 will be 2010 minus 2005. So, of course, we're going to use our calculator and all of that to get 2,997 over 5. Now, that does not divide out to be a whole number, but it does divide out to be 599.4 or approximately 600. What does that mean though? The question asks us to explain the meaning of this slope. So when you look at this, in 2005 we have this number of students. In 2010 we have this number of students. This is a positive slope. Obviously, when we divide this, it comes out to be a positive number. So if we were graphing that line, it would be going uphill, something like this. What does it mean? It means that there's an increase in the number of students, or an increase of approximately 599.4 or 600 students per year between the years of 2005 and 2010. That's what this slope means, approximately. All right, example 8 is another word problem. If you're following along, it's on page 22. It says, in a certain university, the number of students who majored in mathematics in 1988 was 130. So I'm going to write this data again. In 1988, the number of students was 130. By 2006, only 55 students majored in mathematics. Find the slope and explain the meaning of the slope. So this is very similar to the last question we did. We've got years, we've got students, and we're going to make ordered pairs out of them. So those ordered pairs will be 1988, comma, 130 for X and Y, 2006, comma, 55. So this is X1, Y1, X2, Y2. We're going to find the slope. So that slope formula is, again, Y2 minus Y1 over X2 minus X1. So Y2 minus Y1 is 55 minus 130. X2 minus X1 is 2006 minus 1988. And you can subtract those if you need to use a calculator, whatever you need to do. We end up with negative 75 over 18. This is an equal sign here. There we go. If we're dealing with just a pure math question, it's not a word problem, we would just reduce this fraction. But since this is a statistics question, we're going to change this to a decimal. You have a negative divided by a positive. It does make a negative. So this comes out to be a slope of approximately negative 4.17. It's okay to use a calculator if you want to. What does that mean? Because the question asks you not only to just find the slope, which we did, but to explain the meaning of the slope. All right, well, a negative slope means if I was graphing this, the line would be going downhill. Or in other words, something is decreasing. Well, it's obvious the number of students is decreasing. So it's decreasing by approximately 4 per year between the years of 1988 and 2006. All right, we're going to go to example 9, which is on page 23. It says, find the slope and the y-intercept of the equation y equals negative x plus 3 over 5. All right, so this equation is in what we call slope-intercept form. Which some of you may have heard expressed as y equals mx plus b. When an equation is in slope-intercept form, the y is isolated on the left, the x term is here, and then there's a constant term, which may or may not be 0, added to the x term. When an equation is in slope-intercept form, the m, the number, the coefficient in front of x, is the slope. So maybe we'll mark that here. This is the slope, and that's why there's an m there. And b is the y coordinate for the y-intercept. It's not the entire intercept because the y-intercept has a 0 for x, but the b is the y-coordinate. So the directions for this question ask us to find the slope and the y-intercept for this equation, or for the graph of this equation. Well, the slope is the easier part. It's the coefficient. Well, there's no number here. There's only a negative sign. This is, of course, the invisible 1 here. So this slope, and we can use red for slope, is -1. In other words, this line drops off downhill. The y-intercept, let's use blue for the y-intercept here. The y-intercept always has a 0 for x, but then you can find the y-coordinate is this constant right here. So the y-coordinate here is 3/5. Now, a lot of teachers will accept the answer of 3/5 as the y-intercept. Personally, I do not. I will not give credit for you telling me the y-intercept is just a number. The y-intercept is an ordered pair. It's a point, not a number. You need to express your y-intercept with a 0 as x, and then this coordinate here as y. This is how I expect to see the y-intercept expressed. So here's the slope and the y-intercept, and we could graph this, which we're going to do later on here. All right, let's scroll this up. Let's go to example 10. Same type of question. Find the slope and the y-intercept. This time the equation says 3x plus 4y equals 7. And I'm hoping the first thing you notice is this is not in slope-intercept form, which is y equals mx plus b. So you can't see the slope or the coordinate for the y-intercept until you put this equation in slope-intercept form, which just means we're going to isolate y. So we need to get this y by itself. First thing you do is put the x term to the other side. So when you do that, it'll be 4y equals -3x plus 7. Don't forget, when you move a term to the other side, the sign changes on that term because you're subtracting it. And then we need to get this 4 off of this y, so we'll divide by 4. You need to divide every term by 4, and that will give us y equals -3/4. Kick that x off to the side, plus 7/4. And then you can see that your equation is in y equals mx plus b. So the slope is the coefficient here in front of x. So the slope is -3/4, which again means this line goes off downhill in this direction. The y-intercept don't forget, it's an ordered pair. It has a 0 for x, and the y-coordinate you can see down here is 7/4. Again, if you're in my class and you express this y-intercept as 7/4, I will mark it wrong. The y-intercept is a point. It's an ordered pair. It has 2 coordinates, so make sure you're expressing your intercepts with both coordinates. All right, example 11 is on the next page. It's on page 24. Same type of question. Find the slope and the y-intercept of the equation 1/4 y minus x equals 2. Again, when you're looking for the slope and or the y-intercept, you need to have your equation in slope-intercept form, which is y equals mx plus b. So this equation needs to be rearranged with the y isolated. First thing we do is put this x term to the other side. So that's going to be now 1/4 y equals x plus 2. Now you notice I have a positive x here now, where in the last equation this was a negative x. The reason it's positive is because it started negative here. When I move it to the other side, it's now positive. This, of course, is a positive 2, so that's coming straight down. Now, I need to get this 1/4 off of here. To get rid of a fraction in front of your variable, you use the reciprocal. Multiply times the reciprocal. The reciprocal of 1/4 is 4. So we're going to multiply by 4. And you can use 4 over 1 if you want, but that means you also need to multiply this entire side by 4. So these 4's all cancel to give you y. This 4 is going to distribute, I hope you remember distributive property, to give you 4x plus 8. And now you are in slope-intercept form, y equals mx plus b. The slope is here, and the y-intercept is 0, 8, and I hope you remembered to put the 0 in here for x. I think I'm actually going to stop this section here. It feels like this is getting kind of long, and so I will continue this section on the next video. So this will be part A, and we'll have a part B for this section.